Welcome to this short introduction to designing slabs in Tekla Structural Designer. My name is Monica Rennick, and I'm the Analysis and Design Technical Support Manager for Trimble Solutions. In this video, we'll go through the steps for completing a slab design. TSD has enhanced tools to model any of your concrete slab conditions. It performs an FE analysis to mesh the slabs and designs them to ACI 318. You can design a slab supported by beams or a flat slab without supporting beams. You can have multiple slab thicknesses on a single level. TSD supports the design of different slab orientations within the same level and allows you to keep the reinforcement aligned with the direction of the slab. You can model and design column drops. You can also add and perform punching shear checks in the slab. In Tekla Structural Designer, slab design consists of two parts, that is, the design of the slab panel and the design of the patches. The panel considers the entire slab area. It takes the reinforcement required for the maximum moment and applies that to the entire slab. This is considered a base reinforcement and will be placed everywhere. The areas of high moments are then designed separately by the patches. In the panel design, areas within a patch are ignored, so the max moments are not used to design the panel reinforcement. Patches are small areas modeled on top of the slab where additional reinforcement is placed at areas of high stress concentrations. These are designed for an average moment along the patch. Typically, this is the top reinforcement at columns, walls, or beams for the negative bending moment. You can also add internal patches along the center of the slab for high positive bending moments. The use of patches is intended to replace the traditional strip method, that is, using column strips and middle strips to design the different parts of the slab. This method allows you to place the patches only where required and use less reinforcement where it's not. It gives you more flexibility with the arrangement of columns and walls. You're no longer limited to a single line that defines the design area, but instead can now place patches at any arrangement. This method truly takes advantage of an FE analysis. We no longer have to limit ourselves to the strip method, which was created in order to calculate slab moments by hand. Instead, we can let the computer program show us where additional reinforcement is required. Slab design in TSD can be summarized as follows. Perform a full design of the building using either the concrete or the all commands in the design ribbon. It can be helpful at this point to review the analysis results to locate critical areas of high stress on the slab. Next, add slab patches. There are several kinds of patches, including column, beams, and walls. You can also add a panel patch at any location within the slab. Next, run the Design Slabs command. This will design the background reinforcement, what we call in TSD as the panel reinforcement. Finally, run the design of the slab patches. Let's switch now to Tekla Structural Designer to see how this works. This is a 3-story concrete building, slab-on-beam construction at the floor levels, and flat slab at the roof. Before getting started, it's important to review the design properties for the slabs. In the Design ribbon, click on Options, go to Concrete Slab, and review the properties for the reinforcement layout, patches, and general parameters. These will affect how the reinforcement is selected in the slabs. The first step is to run a full design of the building. Use the concrete or the all commands to do this. You could also just run a full analysis if you're only concerned with the slab design at this time. Go to the Analyze ribbon and click on the Analyze All Static command. Once the program has all of the forces calculated, we can move on to step 2. Open a 2D plan view of the level that you wish to design. Change the view to the Results view. In the ribbon, change the result type to the FE analysis. This is the process where the slabs were meshed and contains the forces within the slab. Select a controlling load combination in the loading toolbar at the bottom of the screen. Now use the 2D results command to review the forces in the slab. Look at the MDX top and MDY top to locate areas of high stress in the top of the slab. This is where we want to add slab patches to design the reinforcement for those areas. Step 3 is to add the patches on the slab. There are several patch types to choose from. Patch column places the patch centered at the column. Patch beam places the patch along the length of the beam for a specified width. Patch wall places the patch along the wall. There are additional options within the patch properties for modeling it relative to the wall. And patch panel places the patch anywhere within a panel. You can choose to have it placed at the center of the panel or click anywhere to define the location. Start with the column and wall patches and add more as needed based on the stress contours. Select the patch type. In the Properties window, input the patch dimensions. Click on the column to add the patch. It will be placed at the center of the column. If several columns require the same patch size, you can draw a window around them to apply the patch to all of the columns. Repeat this same process for adding patches to walls and beams. You can also add a panel patch where needed, either at the center of the panel, or uncheck that option to place it wherever you place your cursor. The panel patch will be centered wherever you click on the slab. Once all the patches have been added, we're ready for step 4, designing the slab. In the Design ribbon, click on the Design Slabs command. Once done, the view will switch to the Review view, showing the status of the slab design. In the ribbon, click on Slab Reinforcement to review the bars placed in the slab panel. Notice the Properties window. We're reviewing the panel reinforcement. You can select the surface, top or bottom bars. Also the direction, bars in the Y or bars in the X direction. This command now allows you to optimize the different number of bars used on the project. Select from the current bar and spacing layouts. Click on the slab panel to change it to match the others. That way you can limit how many different bars you have. Once you've reviewed the slab reinforcement, we can now move to step 5 to design the patches. In the Design ribbon, click on Design Patches. We can now see the results for the slab patches. Again, we can click on the Reinforcement command to see what bars have been designed within the patches. The number of bars can be minimized by applying similar size and spacing to different patches. The slab design process may require a few iterations. You may want to review the forces again and modify the slab patches. Once it's been modeled, you can click on the patch, and there are now more options available. You can modify them as needed, increasing the size, or modifying which bars will be added. The patches are analyzed in designs in strips. You can control the size of the strips here as well. We can also see the forces that are being used in the patch design by turning on the result strips. In Scene Content, click on Result Strips. Now in the Results ribbon, select the 2D strip results to view the force diagrams at the patches that are being designed for. It may be easier to view if you turn off the patches themselves. Switch to a 3D view to see the diagrams more clearly. Hover over a diagram to see information about the maximum moment in shears, deflection, and required area of steel. You can also right-click on one of these options and choose Open Load Analysis View. This will open a new view showing the force diagrams for that particular design strip. That brings us to the end of this brief introduction to slab design and Tekla Structural Designer. For more information, visit our website or contact your local help desk.